Hello, everyone. Welcome to the fifth edition of Lead Masterclass. This is your host for the day, Himanshu. At Lead, we ensure that our students should not only be equipped with excellent academic education, but also with skills that help them to succeed in life. Maths can be fun too if students can relate it to real life and are taught in a fun way. To remove the fear of maths in students, we are presenting a Lead Masterclass on mental maths. Our instructor for the day, Mr. Debapriyay, has founded the blog Ganit Charcha under the umbrella of Ganit Charcha, and he and his team work in popularizing mathematics amongst young school students. Mr. Debapriyay Mukhopadhyay has been a corporate professional for the last 20 years and is currently associated with Vehere as a senior product manager. He is working in developing solutions for cyber defense. Sounds interesting, right? Now, kids, while we get ready for the session, please make sure you're telling us in the comment box how excited you feel about today's session. Now, without waiting any further, let's hear it from Mr. Debapriyay Mukhopadhyay.
Good morning, everyone. First of all, I would like to thank Himanshu for this nice introduction of mine. And also, I would like to thank Lead School for providing me with these opportunity to talk about mathematics. As has been rightly said by Himanshu, I had been into cybersecurity and basically in IT profession for last 20 years. But since my basic background is mathematics, so the passion lies there. And out of my passion and out of my love for mathematics, I uh, try to popularize mathematics among students the best I can do and at my own capacity. Now, getting into the mainstream of today's session, which is on mental mathematics. Before I jump into the topic or before I jump into proceeding talks on what exactly I would like to deliver today, I would first tell a few things about mental mathematics. So, in the earlier session with Mr. Ranjit Sinle, you have already seen that mathematics is being used in real life. Mathematics is used everywhere. Now, I will start in the same line that it's not only that real life applications where you can find your mental math skills to be applicable. There are some other places too, uh, which will help you utilize your mental mathematics skills. Now, coming to the real life applications, there are plenty. If you go to a grocery shop, if you plan your timing, if you want to reach a particular distance, say for your school, you have to start at a particular time, then only you can reach in time. So all these things come under the purview of calculating mentally, because you don't sit with pen and paper before starting your school that when I should start for school. So we we used to do these calculations mentally. You used to figure this out that yes, this is the distance that I need to traverse, and this is the time that I have, and this is the different traffic conditions that I have to take care of in worst case. And then given all these constraints, I'll be able to reach in time. So that's our brain, that's the mental math, help you in rapidly estimating the time that it could take to reach a school. So it's applicable everywhere. Even then, why should we uh, learn the skills of mental maths? Is it only just to be applicable in real life? Not all people are learning mathematics at greater detail, but still they are living their life. It's not always that. There are some other reasons if you want to succeed in life. Mathematics is one of the tools through which you can cover great miles. Mathematics is one such tool through which you can uh, get added advantage everywhere in every competitive examinations, in every place entrance test that you will apply for in future. So it's applicable everywhere. It will help you to get success in your day-to-day school examination. I will show at the end of these session that we usually remember multiplication table. You know multiplication table. But even when you don't remember multiplication table, you can always compute that. For that, you don't need to remember anything. But it will take time, right? And that will consume your time in the examination hall. So to reduce that, we have chosen the path of memorizing. So is the case for mental math skills too. If you have honed these skills, if you have been able to practice these skills, if you have been able to take these skills within you, then basically these are kind of armors that you have. Whenever you need it, you can use it at any point of time in your examination hall or be it somewhere else. That will give you competitiveness, that will give you confidence. And this is the confidence, and this confidence which we should try to develop within ourselves, but particularly with respect to mathematics, because people tend to fear mathematics only because of these loss of confidence. And confidence, and you have to think about enhancing your confidence by practicing more. You have to think of enhancing your confidence by utilizing whatever you have learned more and more. The more you apply your knowledge, the more you apply whatever little you have learned, more competitive you will be and more knowledge will come to you. You will automatically be able to figure out the next step. So it's very much important. That's what the main thing that I'd like to convey. And with this introduction, I would like to hear from the audience that if there is any question in this line before I get into the mainstream of today's session.
Sure, Debapriya. Students, thank you so much again, for this quick overview, Debapriya. Students, as instructor mentioned, if there's any question or anything that you would like to ask, we've just uh, also put in the comment box requesting you to ask the questions. If you're struggling with anything, in with respect to mental maths, it's a great opportunity to ask right now so that we ensure that we cover it in this session today, right? So a lot of students, by the way, Mr. Depriya, we have like hundreds of students who are typing in every single minute. They're waiting for the session, and we're receiving so many comments about how excited students are with respect to today's session.
Okay.
uh,
Okay.
So great. I think we can start, and whatever
Yeah.
questions are
Sure.
there, I will keep asking.
Yeah. Sure. Sure. So today I will talk about some basic topics. Uh, Many other things you know, but I will try to see it in some angle. Probably that will help you to appreciate that the different ways we can think about, or different ways we can look at it. Because mathematics is all about asking questions, and asking intelligent questions, asking beautiful questions, and answer to that questions will lead you to the solution. And that's how the subject mathematics has developed over years. And it's very much important to understand the thread through which the subject has got developed. It's not that you have to learn numbers today, then tomorrow you have to learn shapes, you have to learn the next day some data handling and all. It's not like that. Though in usual course curriculum, we usually faces this kind of situation. But even then, when you are studying mathematics, you should follow your textbooks, and you will see that the thread is more or less maintained, and you try to figure it out from with the help of your parents, with the help of your teachers, so that you understand that what comes first and what comes next. It's not that something is coming on top of you all of a sudden. So that basic flow of development we should follow, or we should be able to appreciate or understand. Now, my first question to you is, since you are very small ones, you're young kids, and you have just started learning mathematics, and the first thing with which you have started learning mathematics is basically numbers. Why are numbers important? So that was the first, that is the first question. Have you ever asked yourself, why are numbers important? Now I have shared over here two answers. One is, it enables us to count. That's important, right? If you cannot count, you cannot quantify. If you cannot count, you cannot measure. It's not only just being able to count. How 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 much time it could take for you to complete a sum? How much time it could take from one place to reach to another place? How do you quantify if you don't have numbers? How many hours you have spent in playing some games in a day? How much time you have spent in studying? What is the distance of your school from your home? How do you measure? How do you quantify? So everything is being symbolized by numbers. And from the early days of development, people have felt the need of symbolizing or quantifying these elements which we use in our day-to-day life. And that's how numbers have come. And that's how mankind has started to count. Now, what we do with numbers is it just help us count? And is it only just for counting, or is it only just to be able to measure and quantify? We will use numbers. What about human actions? You have 10 chocolates, and then someone has given you, your parents have given you some 15 more chocolates. You are amazed, right? Why? You know that you have more number of chocolates. You are happy because you have more number of chocolates. But don't you think that your happiness is proportional to how much more you have? So how do you quantify? So will you go on just placing all the chocolates that you have, and then we'll start counting? Yes, that also we do. And that's how we start to learn addition. But You know, at a later point of time, when you come to advanced stages of learning, you just don't do addition just by counting. You are being given other tools to be able to do that. So that's also counting. You have 10, you have got 15, so you have 25. So you can count and can get to 25, or you can use other ways of adding to reach the number 25. So this is a human action that is being modeled. So what is that human action? Basically, you are being given and you want the answer. What is the total number of chocolates that you have? The, the, the term total. So the term total symbolizes an action in this case, and which is basically nothing but an operation called addition. And addition on what? Addition on two quantities. What those two quantities are? Basically, the number of chocolates that you have earlier and the number of chocolates that your parents have given you. And these are being symbolized by numbers. So if I go to next slide, I will see that numbers not only just help you to measure or quantify, it also does that, but it gives you flexibility to model human actions. It helps us to understand human actions better. Now, your parents have given you two chocolates. So sum total of your chocolates became 12. If your parents have given you 15 chocolates, sum total of your chocolates became 25. Now you are more happy when you have 25 number of chocolates together compared to when you have 12 number of chocolates. Now the term more is about comparing. So you are comparing to how you know that 25 is more than 12. That's how your happiness is related to. If I think in that line. So numbers allow us to compare who has got more marks in examination. So that's a comparison. Who is taller than me? Who is shorter than me? So this is all about comparison. Numbers have already given us the tool to be able to measure. And with that measurement, now I can compare. You can order. So 5 friends are standing in a queue. So the shortest one is at the start of the queue, and the tallest one is at the end of the queue. So you can order. You can order according to the marks that you have got. You can order yourself in a class by your roll number. So these are all different type of actions or different type of problems that we face in a day-to-day life, and where numbers are playing vital roles in helping us to achieve that. Now in the next slide, I have written 3 numbers. So what are these numbers? You all will say the same thing what I will say over here. So you will say 12, and then you will say 324, and then you will say 234. Now I have a question over here. For the first number, why are we not saying it as 21? Can anyone answer?
Sure, Debapriyay. So, students, simple question. You see this number in front of your screen. The question that Devis put up is it 12 or is it 21? Why cannot we call it 21? So Sai Divyanshi is saying 12 is a two-digit number. Uh, Santosh is saying 1 comes before 2. There's Abhinav Bijulal. So a lot of students are giving in their comments. They Meenakshi Agarwal is saying, sir, it's one is. So I think students are trying to understand one is before two and hence.
Yeah. So 21 is also a two-digit number, but the answer that you are saying is 1 is coming before 2, and in 21 2 is coming before 1. So you are partially right. Now you should think more. When the number of digits will be more, then you will not be able to say that which one is coming before what and which one is coming after what. So in the next two integers, you see 324 and 234. So if I ask you that why I will not say the second integer, which is 324, as not 234, you have to write it like this. So 2 should be uh, at the first position, and 3 should be at the middle position, and 4 should be at the last position. Then only you will be partially be able to answer that why we should not be calling it as 234. So what matters is the relative position of the integers in a number. So what matters is the place where a specific digit is being used, so that carries a meaning, and that is what is giving the answer that why we should not call 1 2 as 21, we should call it as 12. And that's how the place value system is coming into picture. You have learned in your textbook and you have learned in your classes the place value of a of different integers in a number. So this is the place value chart. So if you see that the rightmost position is what we call ones, immediately on the left side of it we have the tens column, and then we have hundreds column, then we have on the left side thousand columns, and then we have at the leftmost side 10,000 columns. I have just shown these 5 positions. There are many more on the left side of 10,000s. So each of these positions basically is giving you the answer that why you should call 1 2 as 12, not as 21, because when I'm writing 1 2, 1 is coming in the tens position and 2 is coming in the ones position, while on the other hand in case of 21, 2 is coming in the tens position and 1 is coming in the ones position. So that's why we should call 1 2 as 12, not as 21. Now what these positions mean, now if you are given, say for example, some 100 coins, and if you want to count, or if you want to count quickly that how many number of coins you have, so it's in a huge number of coins, so we just go on counting it, because what happens after some time we might even forget what I have counted up to. So we just do bucketizing. So we take 10 coins out of it and make a bucket of it. Again 10 coins out of it and we make a bucket of it. So these 10 coins taking out and making a bucket of it is basically kind of making 1/10. So 10 ones put together is making 110. Now, after counting up to 67, because of some interruptions, probably you have forgot that up to how much I have counted. You don't need to worry about much because already you have created 6 buckets of 10 coins. So while you see that 6 buckets of 10 coins are lying, so you know that you already have counted up to 60. Then you start from 61. So you don't lose much. And when you have more number of coins, then you make a bucket of 100. So 10 buckets of 10 put together will make one bucket of 100. So again, for the sake of simplicity, for the sake of easiness of being able to compute it, we are having these notions of place, and each place is symbolizing one particular value. So once is simply once. Basically, it's 1 to 9. It doesn't carry any other meaning other than 1 and 9. But when I'm talking about tens, it is basically symbolizing how many buckets of 10 you have. So in these example, what I'm showing here, basically 3 is written under tens place. So it is symbolizing that you have 3 bucket of tens. Under H you have 2. So you have 2 bucket of hundreds and you have 5 bucket of thousands. So this is important. And our whole number system, basically up to 10th class, whatever we will be learning or we will be dealing with using numbers, are basically with the help of these place value system or these number system. Now we will look uh, at a greater detail in the next slide, that how this example translates to. So the place value of 7 is equal to 7 ones. So that means 7 into 1 is equal to 7. That doesn't mean anything. It's only 7. The place value of 3 is 3 tenths. So 3 tenths means 1 10 is 10, 2 10 is 20, and 3 10 is 30. So it means 30. The place value of 2 at the 100 place is, because it was in the 100 place, so it's 200s. So 100 is 100, 200 is 200, and the place value of 5 is 5000 because it's in the thousand place, th place. So 1000 is 1 followed by 3 zeros. So 5000 is 5 followed by 3 zeros. And when I put together all these things, I have now been able to count how many number of coins I have. And that's basically nothing, 5, 2, 3, 7 in this order. So 5 has to be stated first because it's in the thousand place. And then 2, it's in the 100 place. Then 3, it's in the tenth place. And then 7, which is at the ones place. So 5, 2, 3, 7 is the number. So now I think you have been able to understand, or you have been able to appreciate that why place value system is very important, and you need to understand very clearly the place value system, because many tricks or many concepts are built around this place value system. And if you understand this place value system better, you will be able to understand the following concepts in further easy, in very easily basically. So now let's move on to the next slide. So You have already seen that how to translate these place value system into a number. So let me ask the simple questions what these two numbers are. So 5000 plus 300 plus 90 plus 2. So what this number will be? You have 5 buckets of 1000, you have 3 buckets of 100, you have 9 buckets of 10, and you have only 2 ones. So what this number will be?
Sure, Debapriyay. So students, you have the question in front of you. A lot of students have started to type in the answers already. I mean, so Ravindu A. Dhaya is saying 5237. Sarabjit Kaur is saying 5392. Divyanshi Satapathy is saying 5392. Aryan Alone,
Yeah, that's
Kausar, Savita, Kanishk, everyone saying 5392.
yes, that's correct. That's correct. It's 5392. Basically, as I have shown in the earlier example, that you have to start with the 1000 place. So it's 5000. So 5 and then followed by 300. So 100 plus comes next. So 3 and then 9 and then 2. And so is the case for the next example too. So here you will be having 7000 and then 400, then 20 and then 5. So put together all these things will give you the number 7425.
Yeah. So there are like students have also given. So Shikharai, Nirmalarmi, Amu, Odia Ghara Khadia, Rashi Tyagi. So a lot of these students are Adya Gupta, Kanish Chaudhary. Everyone's giving the right answers.
Yeah, that's very nice. I'm very happy to see that everyone is giving right answers. So now we can move on to the next slide. So we have seen earlier that how numbers can help us compare. So there are two rules I can think about while comparing numbers. So it's not just comparing 2 and 9. It could be 2 and 200. It could be 9 and 1000. So given all these things, there are only two rules through which you can sort it out, that which number is greater and which number is lesser. So number one, first rule is, if you have more number of digits in one number, that is obviously the greater number. So for example, 109, 100 has got 3 digits, 100, and 9 has got only one digit. So obviously, since 100 has got more number of digits in its expression, so it is greater. So that is the first rule. So there are some examples of over here. So 100 is greater than 11. 2, 3, 4, 5, it has got 4 digits. And 987, it has got only 3 digits. So 2, 3, 4, 5 is greater than 987. 1000, so it has got 4 digits. And 999, it has got 3 digits. So 1000 is greater than 999. So that's my first rule of being able to compare two numbers. Now, what's the next rule? So obviously, the next rule will talk about numbers where two numbers have same number of digits. That's obvious because in the first rule, I have already taken care of most of the digits where uh, one number has more number of digits compared to the other number. So the rule two talks about numbers where the same number of digits are used in its expression. So let's see rule number two. So in this case, we'll take help of place value system. So the two numbers that I am comparing over here is 45678 and 45399. So both of them have got 5 digits involved in their expression. Now we will be starting from the left hand side, that is from the 10,000 places. If the number is even bigger than that, then you have to start from the most uh, the digit which is at the leftmost side. Since I have concentrated my effort over here till 10,000, so I'm starting from 10,000. So if you see the two numbers, if you compare the two numbers, so you can see that both the numbers have the same digit in the 10,000 place. So here it is 4, and in the second number also it's 4. So 4 and 4 are equal. So you now move on to the next one in the right. So that is your 1,000 place. So you see 5 in the 1,000 places in the first number, and in the second number also it's 5. So the two fives are equal. So again, I have to start moving in the next position in the right. So that's my 100th position. So you see, in the first number it is 6, and in the second number it is 3. Now you know that 6 is greater than 3, because it's simple. 6 is greater than 3. You know it's from your knowledge of being able to count, because you know that having 3 chocolates, and what's the difference between having 3 chocolates and having 6 chocolates? You have more number of chocolates when you have 6 chocolates. So 6 is greater than 3. Now, the moment you have got that, you don't need to move to the right anymore. You don't need to check again in the tens position and ones position. Irrespective of what is the number placed in tens position and ones position, you can stop here and you can say clearly that the number 4, 5, 6, 7, 8, which is written at the top, is greater than the number which is written at the bottom, that is 45399. So your place value system is coming into picture over here, helping you to be able to compare very easily. Why? Because if you see this number, you see that you have the same number of buckets when you are considering the place 10,000 and 1,000. But when it comes to comparing the hundreds position, you see that you have 6 buckets of hundreds in the first number, and you have 3 buckets of 100 in the second number. So that's like comparing 6 chocolates with 3 chocolates. So you don't need to proceed any further, because our number system or the place value system is designed in such a way that irrespective of the number being used in tens position and ones position, you have come to the conclusion that the first number is greater than the second number. So that's the rule 2. Please keep it in mind, these 2 rules. You will never face any difficulty while comparing any 2 numbers. How big it is, you will never face any difficulty. Now I'll move on to the next slide. So in my next slide, I'm talking about skip counting. So this is a kind of counting you have heard about in your classes. So we used to start counting from 1, and then 2, then 3, then 4, and then 5. That is being just the normal counting that we have. Now, if we count forward or backward by a number which is other than 1, then we call it skip counting. So other than 1 means, in case of normal counting, when where we start from any number, for example 1, then we talk about the next number, which is 2, and then if I go to the next number, that is 3. So if it is nothing, you start with having 1 chocolate, and then another chocolate you have got 2, then another chocolate you have got 3, one more chocolate you have got, now you have got 4, another chocolate you have got 4. So in every step you are getting only 1 chocolate, and that's how your number of chocolate is getting increased from 1, 2, 3, 4, and 5. So that's normal counting. The moment you start getting more number of chocolates, so you have started with 1, now your parents have given you 2 more, so you have got now 3. You have 3, your brother has given you 2 more, you have got 5. So you are deviating from the normal way of counting. So when we are jumping, numbers, then it's called skip counting. But this jump should be homogeneous. So you start with 1, then you came to 3, and then you came to 5. So every time the difference is 2. Every time you are jumping by one position. So 1, you have jumped from, you have just not talked about 2 and came to 3. Then you have not talked about 4 and you have come to 5. You have not talked about 6 and then you have come to 7. This is what is called skip counting. Now, if I do skip counting by 2, from 2, so we can get these numbers basically 2, 4, 6, 8, 10, 12, 14, and so on. And just the example that I have given a few minutes back, if I start counting from 1 by a skip count of 2, then I will start getting numbers 1, 3, 5, 7, 9, 11, 13, 15, and so on. So the first set of numbers 2, 4, 6, 8, 10, 12, 14, these are called even numbers. And 1, 3, 5, 7, 9, 11, 13, 15, these are called odd numbers. So you know that how I can derive all the even numbers, how I can derive all the odd numbers. So that's how that can be easily be derived starting using skip counting. Now I will go to the next slide. So this is here I am trying to explain skip counting by 3. So you first skip 2 characters, two digits, 1 and 2, and you start with 3, and then you again skip 4 and 5, then you go to 6, you then skip 7 and 8, you come to 9, you then skip 10 and 11, you come to 12, and so on, and I have shown it up to 30. So the numbers marked in red, can you relate it with something? Obviously you can relate it to something because you already have learned the table of 3. So table of 3 says 3 ones are 3, and then 3 twos are 6, then 3 threes are 9, then 3 fours are 12, and then 3 fives are 15, and so on. So you see that through skip counting, I have been able to derive the table of 3. Only thing what you need to ensure that you have to start skipping the first two numbers 1 and 2, and you have to start from 3, and you have to follow the same procedure, and that's how you have ended up with getting the table of 3. But this will not be the case if I start with some other number. So for example, I mark 1 and then I do skip counting by 3, and then I will get 4, then 5, 6 I'll skip, and then I will get 7, then I will skip 8 and 9, I will get 10. So that is not my table of 3. So my table of 3 can be achieved when we start from the right place. So that's how I can remember, I can do away with remembering any table. You always don't need to remember any table. You can develop the table by your own. But what is the downside? You have to do these computations very fast. You have to do these computations on your head and be able to write it while you are being asked to write a table. So in a problem, you have to compute 3 sevens are 21. So you don't remember what is 3 if 3 is multiplied with 7. You don't need to worry about. You just need to put some time, and you can craft and you can find out what will be your 3 multiplied by 7, and that will be 21. But we are being asked to memorize. Why? Because In order to get to 21 through these steps, it will take some time. But if you memorize it, then you can readily apply it. And from these statements, we actually get the feeling of mathematics is being able to memorize formulas, but it's not like that. I'm reiterating once again that it's not like that. Mathematics is not always remembering formulas. You can create your own formulas. You can come up with your own solution. You are being asked to memorize because it will save your time. I have shown you that even when you don't remember it, you can find out what is 3 sevens will be. So is the case for mental maths too. You can compute, you can do many sums, but if you know mental math skills, if you know how to strategize solving your problem, you can readily apply it. You don't need to invest so much of time in solving one problem, because then you probably will not be having enough time in solving all the problems within a stipulated time. So this is one classic example where you don't need to memorize. I'm justifying that you don't need to memorize, you can compute. But there is an advantage of being able to memorize. But what I want to make sure here, you just don't start thinking that mathematics is always about memorizing. So that's what the key thing that I would like to mention over here. Now in the next slide, the same thing is being repeated for 4. Here, skip counting by 4. So the same thing, I'm starting from 4, leaving aside the first 3 digits, and then continuing with the same procedure, skipping 5, 6, 7, and then marking 8, skipping 9, 10, 11, and then marking 12, skipping 13, 14, 15, and marking 16, and I'm getting the table of 4. And it applies to any integer. So by using skip counting, you can get to the table of 5. By skip counting, you can devise the table of 6, and so on. So you don't need to remember table, but you need to remember table because you need to save time in your examination. That's the key thing. That's the key thing that you should keep it in mind. So that is all I have for today. So I will ask if there are any questions on the topic that I have covered, or any other questions on mathematics, or any other questions that you would like to ask. I'll be happy to answer.
Sure, Deb. Thank you so much. So, students, please do type in your questions in the comment box. Anything with respect to what you learned today, or anything around mental mathematics, they will be very, very happy to answer. Uh, there is a question from Gunjan Sharma from Himachal. Gunjan is saying, I'm in class 7th and very average student in mathematics. Can you give me some tips on how to become a maths champion?
Uh, First of all, you have to start thinking in terms of mathematics. So, what do I mean by starting to uh, think in terms of mathematics? Basically, each and every topic that you uh, learn, you have to be able to apply that. But you can only be able to apply that only when you have practiced it more. So each and every topic, each and every concept, each and every problem that uh, you have come across, that your teachers or parents have uh, shown you that how to solve it or how to approach those problems, you have to go through the solutions time and again, and try to convince yourself by asking more questions to yourself, that why I'm doing this step after this step. It's all about being able to answer the question to why. So you should be able to answer why. And the moment you get the answer, you start to be confident about the topic. And whenever trying to solve a problem, you should start whatever you have. You first write down the basic things that has been given in the problem. And then whatever tools, whatever knowledge you have gathered, you try to approach the problem, or you try to attack the problem using the tools or using the knowledge that you have gathered. And then scan through all the statements, following statements that you have written down, and try to figure out what can take you to the next step. And what can take you to the next step only when you will be able to answer, when you will be able to answer the right question, when you will be able to answer the why part of it. And for each and every problem, for each and every question, you should be able to do that. And that will come not in just one day. You will require practice. You will require practice for years. And then you will be able to ask yourself the right question, and you'll be able to see through the question that how I should be able to attack this problem. And then only slowly you start to become an expert, and then followed by a champion. So that's how we should start to learn mathematics.
Right. Thanks, Dave. So there's another question there which is extremely common and popular. So Vivekanand Gaikwad, Hariram Chaudhary, Raksha Kodis, all of these students are asking the same question, that why are students scared of mathematics and in various forms. So like Hariram is saying, sir, students math se itna darte kyun hai? So I think there's a lot of fear in students' mind. Now, would you like to address the reason for that?
Yeah, basically, what I feel from my experience, that students fear mathematics because of the disconnect, because there is a disconnect, uh, the way mathematics is being taught. First of all, I have to be honest, because you see, one fine day, one topic is being introduced, and then 2 or 3 days, basically those topics are being discussed, those problems are being discussed, and then in another fine day, one another topic is being introduced. But it is never told that why this topic has come. It is never told that why this topic will be helpful. It is never told that where or which kind of problems, real life problems, these particular topic will be of help, why this tool is needed, what is the need. So this need part is mostly not answered. This need part is mostly not told. Take the example of today's session, the place value system. It is introduced in class 1, in grade 1, and then it is even talked about in grade 2. But there is a need why this place value system has come, but it is never told, or hardly told, that why this place value system uh, has come, and how we can get hold of this place value system to solve other problems, like for example in case of comparison. So these disconnects remain in students mind, and over the years these disconnects get piled up, and by the time students come to class 6 or class 7, there are so many disconnects, and they only try to see mathematics from the point of view of memorizing formulas. So I have to multiply, I have to be able to remember all the multiplication tables, then I will not be able to answer. But why? You have to remember multiplication table, But you should know the need. The need is that being able to remember multiplication table will help you solve problems in your examination faster. You can come up with the multiplication table by just doing skip counting. For that, you don't need to remember anything. So the need should be stated first before we introduce a concept. The need should be stated first before we start to introduce a problem. And how one topic is helping developing another topic, how another one topic is being followed from a previous topic. That thread, that connect should be shown very clearly from the very early days, and then this fear will not remain.
Right, Dave. So there is another common question there. In fact, it's related to what you're talking about, right? So there's Sai, Divyanshi, Satpati, there is Atharv, Pali Pawar, there is Rudhi Akhade. All of them are asking the same question that, how do we learn? Like, say, you mentioned the skip counting system, right? So they're saying till 10 it is easy, but they have to learn tables from 11 to 30 as well. So is there any quick
Yes.
method or anything that you can suggest on how to do that?
From 11 to 30. So one thing that is beyond the scope of these today's session, but I'm just giving some hints for them to try out. One is, you know the table of 10 and you know the table of 1. So why do you bother remembering table of 11? You can just add the two tables and can get the table of 11. You know the table of 10. That's easy to remember, right? You know the table of 2. So you just add two tables, you get the table of 12. So 10 into 1 is 1. 2 into 1 is 1. So 10 plus 2 is 12. That's 12 in 12 ones are 12. 10 into 2 is 20. 2 into 2 is 4. So 20 plus 4. That's your 12 into 2. So that's how you can compute table of any integer. It's not about just only 11 to 30. So you have your reference from 10, and then just you add up to table up to 9. You get table from 11 to table to 9, up to table 19. And then you have table 20. That's easy because you know the table of 10. You don't have any difficulty in computing the table of 20. You don't have any difficulty in computing the table of 30. And then what about 21? It's easy again. You know the table of 20. You just go on adding table of 1. You will get table of 21. You write side by side table of 20 and table of 2 and just go on adding. You get the table of 22. And that's how you can come up with table of any integer. I hope this answers.
Yeah, yeah. Thank you, thank you. I think we've just time for one last question, right? And that is from Kanish Chaudhary. So Kanish is asking, sir, can you help me understand in these times, all the classes are online. So how do we, like, what are some best practices to study mathematics when it is being taught online?
There is, I don't think there is any difference between how you should learn mathematics, whether it is being taught on a face-to-face situation, whether it is being taught over online. I understand that there is a difficulty in understanding the concept while it is being delivered over uh, an online situation. So my suggestion will be, start to learn to read the textbooks, or basically I see that we don't spend that much of time in learning the examples or what is being uh, given in the book as a practice set and all. So whatever has been taught over an online session, you know the topic, and then you just open your textbook, go to that topic, and whatever you have learned from the class, from the session, you start trying to map it with the solved examples given in the textbook. And before starting to solve any exercise, my suggestion will always be uh, to start with the examples that is given in the book. That will make your foot firm on a particular topic. Automatically, many of the things you will be able to solve of your own from the exercise set. And there will be some difficult exercise for which probably you need to invest more time, probably you need to take help from your teachers and parents. But what I have seen works is basically for any topic, go to the book, textbook, start with solving the examples that has been given in the book. So that's the best strategy to learn any math concept.
Got it. Thank you so much, Dev. Students, we've really come to the end of this session. While we would have loved to continue talking to Mr. Depriya for hours, but we've really run out of time. One request to all the students here, please do fill in the feedback form. It really helps us to improve our further sessions. The link for the feedback form is right at the top of the comment box. It's pinned at the top of the comment box. It's also there in the description of the video. Thank you so much, Depriya, for sharing your journey and tips on mental maths. I'm sure this will go a long way to help acquire one of the most important skills for thousands of students listening to you today. So thank you once again on behalf of all
Yeah,
the students who
welcome.
joined us today for the session. And one important note, students, so the next class schedule for you is at 9 a.m. on January 23rd. So hope to see you all on 23rd January. And please do take out a minute to fill in the feedback form. You can just simply open the link and even fill in the form after this video is over. Right? Thank you so much, everyone. Have a good day.